All right, everyone. Okay, well, while they are answering questions over there, we'll bring a group over here and do the same thing. Does anyone have anything they want to share right now? Any issues, any...
I would like to share progress if I can.
Yeah.
Okay, maybe I will share my screen better, no?
Yeah, okay, yeah.
I have maybe not too much to show in terms of progress. Maybe something like browse my results and see what you can maybe tell me from here, Mike. But I have some questions too. Should I maybe show you first the results, or maybe the questions first?
Well, let's do the questions, and then if
Okay.
we need to look at those results, that might be part of the answer. Yeah.
The three first that I have here, maybe I would like to know. It makes sense to collect in field campaigns data in the morning and a pause, and then in the afternoon, and it will give a sense in SH-Gamut when it processes for that date the data.
Yeah, if you do the Gamut, remember that Gamut processes a UTC day.
Mm-hmm.
So if you do an occupation in the morning, Dominican time, then that will probably be
it's like -4.
Mid-afternoon. Yeah, okay, -4, -5, yeah. In the afternoon, you might, you'll probably be the same UTC day. So you can add both of those files, process for one day, and the data will be included in one solution. Yeah, that's fine.
But I have to merge them before with tech, or I use tech. I know how to use it, but should I merge them or no?
No, it's okay. So this is for the same site. Yeah,
the same site.
Yeah, so when Gamut converts the Rhinex files to the X file, it will actually put all of the Rhinex data into one X file. So it will do that merging for you. Yeah. And you'll basically just have two large segments of data in the X file. That's okay. Yeah.
Okay. Well, that's good to know. And is there any something like a convention to use 3 days? Because I saw it in the testing test, and because I am doing field campaigns in the city, it makes sense to collect data for example, at a period of time of 3 days in a row that will be representative, for example, for January, February, and March. And those 3 days are better than collect, for example, 1 day in January, 1 day in February, and 1 day in March. What is the choice in this case? What is a better solution? I'm talking about one site.
Yeah, it depends what you're trying to do. The idea of doing multiple measurements at the same site over 2 or 3 days is mostly based on the idea that you will not come back to that site for a year or two, or maybe more. So you want as much data as possible in a short time, and you can combine those 2 or 3 days of data to get a much more precise estimate of the position, because you have 48 hours or 72 hours instead of 24 hours.
Well, but Santo Domingo is really accessible for me. So that maybe it's not my case.
Exactly, yeah. So in your case, if you're able to go back every month, you have more frequent data anyway. So if you're just looking at linear velocities, I would say that just measuring 1 day is probably fine. The other thing to say about measuring 3 days in a row is the idea a lot of the time is that you actually take down your equipment and put the equipment back up again with new measurements, so that you randomize human error with things like, antenna heights and things like that. If you have 3 days worth of data or 1 day worth of data and the antenna height is wrong, then that data becomes difficult to use. So, measuring things multiple times starts to add some random element to any mistakes that you might make.
Okay. Well, I have another question. I don't want to use all the time now. I saw that many of the stations are 0 in antenna height, but in my field campaigns I use a pole. I'm planning to use an optical something like tri-brax, but I use, by the time actually I'm using a pole, 2 meters, and I put it, but I saw that many stations are using only 0. Some of them has, for example, some of them have 0.6 or maybe that. It doesn't matter, maybe, because we are in case we use all the time the same height, it's okay, or but why I use 2, or what, or should I use 2 meters?
So who set the antenna height to 0? Who decided to use that number?
In the stations, the data, and the station info, the information that comes from there is 0. In many cases.
Okay. Do you mean for your sites or for other?
No, for the stations in the IGAS or in AFCO.
So someone else asked this question earlier on in the week. For continuous sites, it's often set to 0 because you have some kind of monument, and the idea is that the monument is going to stay there forever, basically, as long as you have funding. And so there'll be a rod, and you put the antenna on top of the rod, and then the bottom of the antenna becomes the geodetic mark that you measure. That's fine if you have a dedicated monument that is going to be there. If you take off one antenna, you put another one on, you might need to just change the height a little bit where it falls on the rod, but you consider the mount to be the geodetic mark. That's not always true when we are doing survey work. Often when we're doing survey work, there's a mark on the ground, like a disc or a screw or something like that. And that is the geodetic mark that we're actually using. So in that sense, if you come along with your pole and it's 2 meters high, what happens if someone comes along later and uses a tripod that's only 1 meter high? They're still measuring to the same mark on the ground. So in that case, I would recommend using the height.
The pole height.
Yeah, the pole height or the tripod height, because the point that you're actually measuring is not the antenna mount, it's the mark on the ground. Yeah.
Makes sense. Okay, makes sense. Okay. Well, thank you. I have more questions, but I don't want to use all the time, no?
Okay. We can come back then with the other questions a little bit later.
Okay.
We'll go on to Nate has his hand up. Do you want to share something with us, Nate?
Oh, sorry. I was talking, but I wasn't there. So, So I successfully ran a gamut run. I had a bunch of errors, but they were mostly due to the station info files or the APR coordinates. And I found that the APR coordinates, if you didn't include it in IGS file, were really bad, like thousands of meters off in the vertical. So I fixed that for now by pasting in the coordinates from the Rhinex file, which were much more accurate. But for some of the UNAVCO stations, I got the same error. And I didn't know exactly where to fix that, so I just pulled the station out of the analysis. Would I put that in the APR file as well, or?
Yeah, excuse me. Yeah, this is exactly what happened.
I think you might have come across a similar error.
Yeah, it sounds like almost exactly the same thing that I came across in my demonstration earlier on. So the solution is, as you say, to actually include the UNAVCO sites in your APR file or somewhere that GAMET can access that coordinate. A lot of those, I've been meaning to add those coordinates to the IGB 14com.apr file, but haven't quite got around to it.
The fact that it's not in the APR file, it's not that it is in the APR file and it's bad coordinates.
Right. So we actually do distribute, if I remember rightly. Oh, no, let's see. Yeah, so we do actually have a set of files in GG tables that are PBO files, and we can just use the IGS14.apr file, and this actually has the coordinates for all of those gauge sites in it. So you could just go and grab the site that you're missing from this file and add it to whatever APR file you've been using for the start of your run. And that should solve the problem.
Awesome. So yeah, that's my main question, and I'm excited to see the gamut run. So I'll hold my other ones, or sorry, the Globe K run. So I'll hold my other questions till later.
Okay. Yep. Sounds good.
Thanks, Mike.
Yeah. And so Joshua, you wanted to share something after Nate's question there. So let's move on to you, and then we'll come to the others who have their hands up.
Yes. So it's exciting over here. I have a initial run on results at this point. All right. So this is the 2022 directory within which I ran gamut with after renaming all the files.
Yep.
Have lots and lots of output. I don't see any, I did not notice any errors while compiling this. So I guess the next step is just kind of like perusing through these results to see if there's any kind of like, I guess, obvious errors or anything like that.
Yeah. So often what we would do is if you go into that 060 directory, much like we did yesterday, we looked at the sh_gamut_060.summary file. And that will be a good place to start and see where we went. Okay, so we have input options, and we got 11 files being processed. Okay, all of those numbers look fairly good. You can refer back to one of the lectures that we had maybe on Monday or Tuesday regarding what this file kind of should look like for a decent run. One of the key things here is you have a post-fit NRMS of about 0.2, which is normal. Your post-fit RMSs, the best and the worst two sites up there a little bit above, are 10, 12 millimeters, something like that, which again is quite normal. And your ambiguity fix rate is pretty high, 85, 95%, somewhere in there. And that is what we would expect for modern data. There's no additional error messages. There's nothing about post-fit or pre-fit adjustments to coordinates. So this seems like a pretty well set up experiment that has run as normal. Yeah. And you can just check those numbers in the other day directories as well. But yeah, everything looks pretty good there.
All right. Let's get a post-fit RMS of 2.
Yeah, you're breaking up a little bit, your voice. I don't know if that's me or you, but yeah.
So you say a post-bit RMS of about 2?
Yeah, the 4 lines there under double difference statistics. Yeah, lines 21 to 24. Yeah, those values there, they're for the 4 different solutions that Gamut produces. We're actually just going to use one of those 4 different solutions in globe K, but it's the last line will be the one that we actually use. But all the numbers are approximately the same for the different solutions. Yeah, that number being about 0.2 is indicative that there wasn't any overly constrained data or bad data compared to the default setup of Gamut's codes.
Fantastic.
Yeah,
that's awesome. Yeah, I will just continue perusing these results, and we'll stand by to watch the globe K demonstration, and we'll follow along where I can.
All right. Yeah.
All right, thank you.
Good stuff. Okay, let's move on then to Taha. I think you had your hand up there.
Yeah, I'm here. Do you hear me?
Yep.
Okay, I have to share my screen first.
Okay.
Okay. Actually, I changed my location of study for the third time, and yeah, and also I tried to include include 12 different stations with actual coverage or almost 20 kilometers. So imagine that it's a little it's a small circle area that covers the whole area. So I ran successfully the SH gamut. So I have the figures or the summary file that they are here for only 3 days, because I increased the number of stations and there's no time for processing the many days. So I only include 3 days, and I ran it successfully. But the problem is that I still have a little problem with the SHGRed. So I ran it, and there is no error, but still you see here there is it's make the plots. But the problem is that when I look the plots, for instance, for this one, I don't know, it doesn't shows bars, it doesn't shows any significant results.
Yeah.
I don't know what is the problem.
Yeah. So this is coming. You said that the network you chose was very small. Is that right?
Yeah, it's not. But but I used two of those 12 stations a little far from the local stations. All of them are the IGS stations. So I particularly chose them because I didn't want to include the APR file by myself, because I wanted to decrease the error sources. So yes, the 2 of these stations were far from the more of those 10 stations to fix the reference frame. But I guess I need to again increase the distance from the local stations, right? Or there's other problems.
There's 2 things that are probably going on here.
Okay.
Number one is, yes, you still don't have enough distant IGS stations to satisfactorily define the reference frame. It's really critical in order to get these results being meaningful results, it's really critical to get to this last stage and be able to define the reference frame well. And we can only do that with a certain amount of redundancy in the data. If you choose two sites, let's think about this in a sort of numerical sense. You've chosen two sites that are distant, and they are able to control the definition of the reference frame, well. But you are estimating 6 parameters for the reference frame definition. You're estimating a rotation around the x-axis, a rotation around the y-axis, a rotation around the z-axis, and then translations in x, y, z as well. So 2 sites with 3 components each, where we effectively downweight the vertical component. So really 2 sites only means 4 components. We're using 4 components of data to try and constrain 6 parameters. That's a little bit of an underdetermined problem.
Yeah, okay, yeah, I see.
Yeah, so that's why we need this redundancy with the IGS sites,
Okay.
maybe 10 or 12 at minimum at a large distance.
Okay.
The other thing that might be going wrong here is because you've got such a small network, over a very small section of the Earth's surface, rotation and translation effectively trade off with each other because there's not very much curvature over a very small space. So when you estimate rotation and translation over a very small area, there's a lot of correlation between those parameters and they can trade off. So over a very small area, we would actually switch off the rotation estimation and reduce the constraints on the EOP parameters that define the orientation of the system. And that is covered in the old example that we don't use anymore. I can show you briefly if I share my screen. In the standard globe-k command file, down where we constrain the rotation parameters here, normally the polar wobble, which is the polar position, and the UT1, which is the rotation rate around that pole, those 3 parameters define the orientation of the axes. Normally we keep those values quite loose, but the note underneath here says have the EOPs tight if you're doing a translation-only stabilization in GLORG. And this would be for small networks where you don't have very much distant curvature of the Earth. So you would actually comment out these lines and uncomment these lines if you wanted to do a translation-only stabilization. Then in the GLORG command file, up at the very top here, you see the parameters that we are going to estimate when defining the reference frame. So normally we use this line, X, Y, Z translation and X, Y, Z rotation. But here it says, or if you're doing translation only, we would use this line instead. So again, you would comment out this line and uncomment this line. So we do, for a small network, we do only a 3 parameter reference frame definition. And we keep the rotational component a little tighter by constraining the EOPs. That should improve those error bars for a small network. And that is, those 2 things combined, if you want to go with a small network, that's fine, but do translation only stabilization for the reference frame, or just add more sites that are at a large distance at the very beginning, and then you can do translation and rotation. So one of those 2.
Okay, that makes sense. Thank you so much. Thanks.
Yeah, sure. Okay, great. Carissa, you have your hand up as well. So
yes, now I can share my screen. So let me find the. I think this one is still processing. Can you see it?
Yep. Oh, I can see a fatal error. Yeah.
Okay, yeah. One question. At first, I ran SH Gamut for the day of year 213, and it's ran, you know, without any problem and without any fatal error. Also check the summary. But when I just changed 213 to 214 for the next day of year, again, it gives me this problem because while you was answering the questions, I had this problem and delete everything and started from scratch. So again, I had this problem with the day of year 214.
Yeah, this is probably an issue with your environment, your computer's environment, specifically what we call the locale. So can you run the command print env, all one word, print env.
One word, okay.
Yeah, there we go, yeah. And then let's look for your language setting. So you have German, I guess, Luxembourg, German, Luxembourg, yeah. Okay. In many languages, specifically languages like French and Spanish and Italian and those kind of languages, the convention for numerical values is to use a comma for the decimal point instead of a dot.
In the station profile, okay.
And so, no, not in the station.info file. No. So I'm just explaining that some languages have a different way of writing numbers. So in some languages, the thousands separator is a dot and the decimal separator is a comma. And in other languages like English, the thousands separator is a comma and the decimal separator is a dot. For numerical computing, these codes work on the assumption that the decimal separator is a dot, like in English.
Right.
And so what's happening here is you have numbers being written, like 0.00 is being written as 0, 0. And that is then causing issues with reading that number in the processing stage. So the solution is, can you see at the bottom there, there's an environment variable called LC numeric.
LC, this one.
That one, yeah. So what we need to do is we need to change that to C, capital C. You can do that in your bash command file. What shell are you using?
I use bash, right?
Bash, okay, yeah.
Nano, this is the file, right?
That is a text editor, yeah.
Okay, what was the name of the file?
You might have, no, it's in your home directory. You might have, yeah. And then just do an ls-a there.
Yeah.
Okay, so you have a .bashrc file and a .profile file. So let's have a look at your bashrc file. Okay, and then just go down to the very bottom there. Okay, right. And now let's quit and have a quick look at your .profile.
Okay, no.
Okay, great. Yeah, so this will load bashrc anyway. Okay, so let's go and edit .bashrc.
Bashrc, okay.
Yeah. The dot at the, dot at the beginning.
Yes, I can just.
Yeah.
Okay.
Okay, and down at the bottom, I think you had your paths set for Gamut Globe K. There we go. So we could add another line underneath that that is export LC numeric, all in capital letters.
Let's see. It was an underscore between them, right?
Yeah.
Numeric.
And then no space.
Okay.
Equals. And then in single quote, I do a single quotation mark. And then C, capital C.
Capital. Okay.
Yeah.
No.
Uppercase. Yeah. Okay. That should be enough. You can quit that. Save that.
Yes. Control X.
And then you'll probably need to open up a new terminal window just to refresh the environment.
Or source.
Sometimes that works, yeah.
So let me open another terminal and share this one. So it was print env.
Yeah. Okay, great. Yeah. Yep, that's set now. So basically what that does is that environment variable sets any numerical values to use the C convention, like the programming language C. So rather than using a language convention, it's actually going to use a numerical computing convention for any numbers. And that should help solve this issue. And I think Francesco wrote in the chat as well that he found the same problem with Italian. We actually, if you close your screen there, and I'll share my screen quickly here. Just for everyone's information, this is a useful thing to know. In the Gamut Globe K website, we do actually have this known issues webpage. So if you ever have some problem that you don't understand, sometimes it's worth just going to this known issues page and seeing if we already have a solution for it. In this case, you are seeing the same problem as this third bullet point here. The error message was a little bit different, but the solution is the same. And as you can see there, the solution says, set a separate environment variable for numbers, LC numeric, to C. For example, in bash and shells, we add this line to bashrc profile or bash profile. It depends which file you have on your system. Or you can do setenv LC numeric C if you use C shell or TC shell. And there's also a note about this in the README file for the software that we distribute with the source code. So sometimes, just going to this web page can help a little bit. And this is a common thing. We probably should update our scripts to always include this line at the top so that this doesn't become an issue with people. But it's often an issue with non-English languages, unfortunately. Yeah, but that's
thank you. I don't know even one language, one word in German. It was the IT reinstalled my computer and they changed the language in German. So I didn't aware that it can cause a problem in processing.
Yeah.
Yeah, okay. And I have another question. If we have time and there is nobody can want to ask a question. Or
there's a question in the chat, but I can come back to that if you want to keep going for the moment. Yeah.
Okay, yeah.
I've lost I'm still sharing my screen. I need to switch that off. Where did my thing go? Oh, there it is. Yeah, okay. Stop share. Great. Yeah. Yeah, do you want to ask your question?
Okay, it's me or the other person?
Yes, yeah.
Okay, yeah. So in this directory, in 213, it could, like yesterday, I have this file for 213. Oh, it seems that. And I just wanted to see quickly the residuals for that day for all the 6 stations. Although I added, let me show you, I added the command in sh_gametes, but I just have the, the sky plots. Okay. So I wanted to check with you, what is the option that I can, before going to GlobeK to have the time series, to just quickly check the residuals for each station and then go back to the next step.
So you want to see the elevation angle residuals as well? Is that the question?
Yeah.
Like
all
the
figures that you can check, okay, for this station, everything was fine, and I can go for the next day and continue. Because the problem for these stations that I've already mentioned, sometimes we have some problems and we want to make sure, because my colleague is also working with Gypsy, and for each day we are comparing our results. And as soon as it's okay, we go for the next day.
Okay, so when you say residuals, what quantity are you talking about here? The phase residuals or the position relative to some known position or something?
At first, the phase residuals, and I think for the position residuals, I need to compare it with another source. So at this step, I cannot see the position residuals.
No, because we haven't run GlobeK yet.
Yeah.
Gamut just produces what we call a loose solution. And GlobeK actually adds additional constraints and does the reference frame transformation and all of that stuff that we've talked about. And it's the output of GlobeK that is your final position that you would see, plotted on a time series kind of thing. So these are the phase residuals from the gamut fit, but we haven't yet made final positions.
Mm-hmm. But in this step in gametes, we cannot even see the loose solution, and for the phase residuals for the loose solution.
Again, I'm not quite sure what you mean by residual. What quantity are we talking about here? Position, phase?
No, phase residuals.
Phase residuals. Okay, so that's what's plotted here. I don't know anything about what Gypsy produces, so I'm not quite sure what you're trying to compare. Are you looking for a number?
If it's possible, I can show you, because I have the figure. Okay, so let me stop sharing, and again. You see, for example, this is the residual for one of the stations for Basharash, for the first one.
Okay, so this is again phase residual, right?
Yeah.
Yeah, okay. And on the x-axis, is that elevation angle?
I think, yeah, it's the elevation angle, and for just one station.
Okay, right. So yes, Gamut can produce those elevation angle dependent plots, and the option in SH Gamut is and so the option is this plot residuals, P-res option. Plot gamut residuals, phase residuals. as sky plots, no or yes, or do the sky plots plus the phase versus elevation. And if you want to do the sky plot and the elevation residuals, you need to have elev as the option. So it would be SH gamut, all of your normal options, and then minus PRes elev. That would be what you use.
So I just used this option and get those sky plots. And I think those phase residuals are also plotted in the sky plots, right? Because it automatically plots both of them, the phase residuals and the sky plots.
Yes, they should both be in the figs directory. Yeah.
Okay. But there's no option to have the phase residuals separately, not in the sky plots.
You mean like that figure that you just showed me?
Yes, yeah, exactly.
That is what this option is. You will have the sky plots, and then you will have another figure showing the elevation angle versus the phase residual. There will be two plots. At the moment, you have one plot per site per day, but if you use the elev option, you should have two plots per site per day. One is the sky plots, and the other one will be the elevation angle plot.
Yeah, it has a suffix. The suffix is elev res PNG.
Yeah,
it's different. She doesn't have it.
Right. Yeah, it has a different file name. Right.
Mm.
Yeah. And this is what you see from the test install as well. Is this option is used, and then yeah.
Okay, good. Thank you.
Yeah. So maybe just check. Or in fact, can we look at the SH gamut summary file for day 213?
Yes. So can I share?
Yeah.
So if I go back, specimens. You see, I use this.
We only see the directory window, not the text.
Okay, so let me. SH gamut summary, right?
Okay. Yeah, I think it needs to be in uppercase.
Okay.
Letters. It's important, if the gamut help page says, no in capital letters or yes in capital letters, it's good just to use the option exactly as described in the help. So in this case, I think it probably didn't read that properly because you used lowercase instead of uppercase. That's probably the issue. Yeah.
Yeah, it's so sensitive. Okay, I will just change it and run it again.
Yeah.
Good.
Just bear in mind what we said yesterday or the day before as well about you're comparing gypsy processing with gamut processing, and we have quite different weighting schemes for the data as a function of elevation. Gypsy is far more aggressive at including, is far more aggressive about including the low elevation data, whereas gamut is a little more conservative. And you can see that in the scatter. In the gamut plots, you will have these envelopes that track the data, and that is the weighting model that is used for the phase data. So just bear in mind that the residuals might not look
the same.
The same, just because of how they're weighted.
Yeah, I got it. Yeah. Thank you. Thanks a lot.
Yeah, sure. Yeah. Okay, Francesco, I know you have your hand up, but I'm just going to go back to the chat to answer Arif's question quickly. And so the question was, we're almost doing GPS surveys for each site at least a full day, but on average 36 hours. Okay, one team collects meteorology data and another team doesn't. What's the significance of the MET file for deformation survey processing? Okay, so the MET file, if you collect it, is simply a surface measurement of pressure, temperature, and usually humidity as well. From those quantities, we can estimate the structure of the atmospheric delay just from surface observations alone. This is the way that survey work used to be done 20 years or so ago, because the weather models that help us constrain the atmospheric delay were not particularly good. So you needed surface level meteorological measurements to improve your a priori atmospheric delay model. Nowadays, the global scale numerical weather models are always available. We have them built into Gamut now. So a lot of the atmospheric delay parameters are taken from the numerical weather grids that we provide. So this is the VMF1 grids. Alternatively, there's some empirical models. So I don't know how much the MET files are actually useful anymore. I don't know anyone who uses MET files anymore, but it would be an interesting test to do, using the MET files that you have gathered in the field, processing with those versus processing without them and relying simply on the VMF1 grids, or alternatively the empirical model, the GMF model, sorry, GPT model. So yeah, the results should be mostly compatible. There should not be a big difference between those two different approaches. But most of the time now, people don't make meteorological observations anymore because the numerical weather models are much better and they are incorporated into the software now. Yeah. Okay. Oh, Francesco, you had a statement about what we were talking about with the residuals, just to say that GPCX produces the phase residual over 24 hours, not along the elevation as, oh, so that was time on the x-axis? Is that right, Francesco?
It is the figure that Paris show is along 24 hours on the x-axis.
All right, so it was time.
So it's different. It's a different way to observe the same. Not
Okay.
along the elevation, but just along the on time. 24
Yeah.
hours observation.
Okay. Yeah, in that case, I don't think we have any scripts that plot that particular, phase residual versus time figure. I don't think we have anything that does that, but you could plot those values for yourself, because the phase residuals are saved to a file. You just need to make sure that you keep that file. So let me show you that briefly. Did I finish that Geyser's stuff? Okay, perfect. Right. So all of these, where's my mouse? There we go. All of these DPH files are basically delta phase. They're phase residual files for a site and a satellite. So for each site-satellite pair, there is a phase residual in these DPH files. So let's just look at Quinn for satellite number 1. Here, I'm going to just reduce my text size a little bit so that we can see everything on one line. And so here we have the L1 cycle and the P2 cycle. The LC which is the linear combination. And whoops, just clicked on the wrong part of the screen. Okay. And the elevation, angle, and azimuth, that helps plot these things. So you could plot the LC cycle, I think, would be the one that you would want to plot to see the residuals over time. And this is just epoch 1, epoch 2, epoch 3, epoch 4, and so on and so on. So that's just the number of 30-second epochs past midnight, the beginning of your day. So you could do that. You could do it that way.
Yeah, thanks. I can plot for the comparison.
Yeah, and I think these are in millimeters, if I remember rightly. Oh no, sorry, they're in. I think they're in L1 cycles. So you would have to multiply up by the wavelength of the L1 cycle. I can't quite remember. Yeah, okay. All right, the script that plots this stuff anyway is, you can look at what the script does. Let's see here. Residuals, yeah. Let's see. Yeah, I can't. The script that does the plots for us is SH1 way. So there's a lot of stuff in there that reads those DPH files and extracts them and does some calculations to produce the residuals plots. So you might need to just read through this to be sure that you're reading the right column and subtracting the right things or multiplying the right things. I haven't looked at that in a long time, so I can't really remember what those values are. But they're the files that you could read. They're the phase residual files.
Great, I will go through the file. Yeah.
Yeah.
Okay, thank you.
Okay, so we have another question in the chat, and it is, can someone put here the gamut globe K update command? What do you mean by the update command? What are you trying to update? Are you trying to update the source code? Are you trying to update the tables? Update the tables. Okay. Are you referring to what we talked about yesterday with updating the EOP tables? Is that what you're asking about? The easiest way to get those updated EOP tables is actually just to copy them from our source code server. But if you want to do it yourself, the command is sh update EOP. But that's only for the EOP tables. That's not for all tables. So yeah, let me know exactly what you're asking about, and I can change my response. But if you're asking about what we saw yesterday with updating the EOP tables, the command is sh update EOP, and you need to add some options to that based on the help page. You want to update all the files in the tables directory. Okay, in that case, you need to install the incremental updates. So that would require going to the source code server. You download the latest incremental updates package, and then you can run the install software. So that's what you would do to update everything. Yeah. Okay. Yeah. Just install software. Francesco, you have your hand up.
Okay. Can you hear me?
Mm-hmm.
Yes. I have a question about reference frame. So because I see the beginning, one guys have a small network with no stabilization and so on, I think. So I'm process again my data with block K, using a new glob K command file, and I have problem to mix, to combine the solution in order to have a position or a velocity. And I have maybe it's better that I show my screen. Is it possible? Here. Can you see?
Yeah.
So I use this command file on the left, and I have this noisy, all are the same file that I used before, so they're the same. And when I combine, I have this value high, very high, and I don't know. It's I have some, I don't know. Maybe there are some constraint in the command file that it's better to change, because
these numbers are very big. I don't know where it's coming from. This is something where it would be a lot easier if we were in person, and then I could like take your computer and just try and figure out what is in these files. Numbers like that. Well, are you doing a velocity run here, or is this?
No, I just not the velocity, but position.
Okay, so let's see what you did at the top.
Yeah.
Okay. All right. Go up a little bit. And you're using. Okay, so
I use. So maybe it's better that I'm gone a bit.
But you used what command did you use here? Glob K, GL.
Glob K.
Glob K. Okay. And what's the date of your first file?
Yes.
Is okay. All right. I see what's going on.
November 2014.
Okay, I see what's going on. Yeah. So go back to your glob K commands a little bit above. You highlighted it a minute ago.
This is
you have the APR.
It is the same, and it's on the left.
Okay, yeah, sure. But you have a APR NEU line.
APR
NEU. Yep, there, right. So you have for all sites, this line says for all sites, consider the initial sigma to be 20 meters in X, Y, and Z, and consider the initial velocity sigma to be 0 in X, Y, and Z. Now, the way that GlobeK interprets that is that you do not want to estimate velocity. So it is switching off, you're estimating position only, no velocity. But because you ran the program GlobeK, GlobeK combines all of your H files together into one solution. And so you are using files from 2014 combined with files from 2015, combined with files from 2016, but you are not estimating velocity. You are not allowing the position of the sites to change with time. So the result gets progressively worse because you are trying to estimate position only with 0 velocity. The solution in 2021 is not allowed to move relative to the positions in 2014. So the fit becomes progressively worse.
Yeah, until this year is...
Yeah, there's 2 things that you can do here. Number one, if you want to combine all of the H files together over several years, you need to estimate velocity. Mm-hmm. The second thing is, if you just want to see a time series where each individual file has a separate result, then we use the program GLRed, not the program GlobeK. So you have a choice of what you want to do there. Either you do the GlobeK combination and you estimate velocity over time, or you do the GLRed time series with individual results each file.
So in this case, it's better to use, with this line, this command here, it's better to use GLRed, right?
Yes, exactly. Yeah, if you use GlobeK, I would add the vel keyword so that it reads that line exactly. Yeah.
Okay. Oh, we can just we stop a moment. So I will do this right now and we will see.
Okay, great. Now, who was it who wanted to share their screen there? Jose? You want to share your screen again?
Okay, if it is okay, let me see. Well, not only to show you the my results from the SH gamut workflow. Only for that. Yeah, maybe so. I see everything is okay. Maybe not, but I don't know if I can maybe rerun with some other parameters. But I think that everything was really okay. This is for the day 82 of year 2020. Mm-hmm. 2022, excuse me, and this is for the day 131. Well, my stations, my base station in my house and is MGGA. Well, I'm going to read here. MGGA is and Alma is the field station that I use it for this run, but I plan to include maybe 4 stations more and many days more that I have in my database now. So I don't know if there is something really, well, some example, MGGA was the worst. I didn't expect that, but maybe, well, I don't know exactly why that happened, no, but. Well.
Is MGGA the site where you have the uncalibrated antenna?
Yes. Yeah. Okay, things are making
that
sense.
that might be why. I don't know for sure. It might be the quality of the antenna. It might be the calibration. It could be the receiver. I'm not really sure why, but it wouldn't surprise me if it's because of the uncalibrated antenna, because we did fake the antenna yesterday. Yeah. So my guess is that that's probably the issue. But maybe that's okay. It depends. You're looking at a very large signal, so that could definitely be improved until you have more accurate calibration and more accurate a priori coordinates. Maybe it might look noisy with this high RMS.
Or maybe excluding my base because it is only 2 kilometers from the IGS station. Maybe my base station is not really providing anything else, anything interesting here.
Yeah, maybe, but I would still include it in the processing. Okay. You can make that decision at the end when you do your analysis. If it's not helping with the analysis at all, then okay, that's fine. But at least you still have the result, and you can look at the result. I wouldn't exclude it at the gamut stage. Yeah.
Okay.
Yeah.
Well, and in the summary was really. I tried 21 sites, but excluded 4. Maybe I remember I dig a bit in that. Those days in some sites were not included.
Yeah.
I don't know exactly what was the reason, but maybe it was that because some sites are having problems here in the.
Well, MGGA on your screen there shows 16.5 millimeters of RMS, so that's much better. So perhaps the previous high number was maybe because the a priori coordinate was just not very accurate. But because Gamut updates the a priori coordinate, if it's inaccurate, it updates it to a new version. So maybe as you went through these days, the first day was not so good, but the second day was better because the a priori coordinate was better. So this, I don't know, maybe that's, yeah.
Okay. That's good. Well, I don't know. It was a question that I have here. No, I put in the first place, I put my NRCan coordinates that I obtained from the PPP services from Canada, no? And it didn't work. It didn't work, and it was shifted a lot of meters from the solution that I generated with SH to APR. I don't know exactly what, but the solution, I thought that the solution from an NRCan and OSPOS, they are consistent between each other. I thought that they were good solutions, but now I know that maybe they are not good solutions.
Yeah, I don't know. I don't know what NRCan does. I'll load up a Rhinex file over lunch and I'll see what output they provide and things like that, and then I might be able to answer that question a little bit better. But we are at lunch now, so unfortunately we didn't get around to doing any demonstration, but the questions were very good. I'm glad that people are continuing to share their screens and working through these problems together, and then going away, improving their processing, and then coming back to show how things had got better. This is really great, and I think this is the way that we think that these courses should work, and we think this is the way to get the most progress. We'll go back to the main room now. I'll close this breakout room. We'll see if anyone else is there, and then we'll break for lunch for an hour. I think we have another lecture after lunch. Yes, we have another lecture after lunch. And then the whole of the rest of the day after that lecture is interactive time. So we have a good 2 or 3 hours of interactive time to finish the day. There'll be lots of time to finish on that.
Okay, that's good. Thank you.
Okay, great. And Francesco, great. I'm glad to see that it's a little better now with those velocities switched on. Okay, I'll close this breakout room now, and we'll break for lunch.